Hello, I think it's time to start. So let's talk about materials and effects in Qt 6. I'm Laszlo, I work at the Qt company, and I'm usually working on all sorts of graphics related things in Qt. So this includes Qt Quick, the Qt Quick SceneGraph, Qt Quick 3D, and all the enablers, graphics related enablers that sit underneath, for example, the new graphics abstraction layer in Qt 6. And I've been also looking at all sorts of low-level platform-specific details. So in short, I'm doing all kinds of work that's relevant for enabling Qt to render either to an on-screen window or to the screen of an embedded device or even off-screen. Those of you who have seen my Qt World Summit talk last year at the previous World Summit, those may remember that there I've been talking about the big new thing in Qt 6, which was the new rendering hardware interface, or new graphics abstraction layer, which allows Qt, so Qt Quick and Qt Quick 3D, to render not just through OpenGL, but also with other accelerated 3D graphics APIs, such as Vulkan, Metal, or Direct 3D. And this is, of course, very good for Qt 6 applications, because now they can use on every platform the platform's best supported graphics APIs, not tied to just OpenGL. In this talk, however, I want to focus on one subset of this big, wide graphics area, graphics topic, which is the case of application-provided graphics shaders. So this is the case when an application implements a material or effect where custom vertex or fragment shader code is provided from the application to Qt, so to the engine, to the framework. So in Qt we have, of course, Qt Quick to do 2D-ish things, and of course in Qt Quick we have the concept of materials, and you also have custom materials, which is where you subclass QSG material shader in C++, re-implement a few functions, and also specify some vertex and fragment shaders. Then we have ShaderEffect, which is something we will have a closer look at in this talk, which is a Qt Quick item. So there you really work from QML, not really with C++. In the Qt Quick 3D world, we also have the concept of materials and effects. When it comes to materials, we have custom materials, which are a very powerful tool to get good-looking 3D scenes. But unlike Qt Quick, where the custom material is something you would implement in C++, in Qt Quick 3D it's a bit different. So this is again a QML item, let's say. It's a custom material, and then there's some associated vertex and fragment shader code. And where it comes to 3D effects, so we have the concept of post-processing effects in Qt Quick 3D, which is conceptually quite similar to Qt Quick, the 2D effects. They can do a bit more, like, for example, now there's a depth buffer, or there is some support for doing multipass things, but the basic concept is the same. What that concept is, we'll see soon. And then, of course, there are other places in Qt applications where you would, of course, work directly with shader code, such as, for example, if you are using Qt 3D in your application. To quickly define what this whole material effect, what are these, I have some very, well, maybe oversimplified definitions here, but what matters to us here is that the material is used so whenever we have a mesh, so we want to render it, and we need the shaders, and we also need to know some graphic states, such as what is the blend state and depth state and stuff like that. So how to configure the graphics pipeline. So that's what the material is. Of course, the graphics pipeline state part you don't really see in Qt Quick, but in it might still become more visible on the 3D side of things. Whereas an effect is similar only in the sense that, okay, there are some application-provided shaders, but the concept, that's totally different, right? Because what we do is that we render a scene or a sub-scene, just a part of the scene, into a texture, and then do something with that texture. That's typically done by drawing a quad, so two triangles or something, and then have a shader that samples that texture and then does something to calculate the final fragment color based on the color that was sampled from the texture. So here is a QtQuick, well, let's say application. So what does this do? There are two visual items in the scene, the rectangle and the text. There's a gray rounded rectangle and some text on top. Fair enough, that's simple, so not much to add here. What's interesting here is that if I take a capture with RenderDoc, for example, or I could use some other tool, but here is a capture when I'm running this on Qt6 with OpenGL as the graphics API, I see that, oh, there's a clear and then through two index draw calls. Presumably the first one is the rectangle, 122 vertices, it's quite a lot, but that's because it has rounded corners, and then there's the text. Okay, not much to see here. When this becomes more interesting is that if I add this layer.enableTrue line, the output is completely the same. But under the hood, again, look at the frame capture. Now there are like, yeah, looks like two render passes. So first, there is now a texture of the size 300 times 300. So this looks like that, yeah, we rendered the rectangle and the text into that texture, and then there's the GL draw elements 4. So 4, that's presumably a triangle strip. So yeah, we get a quad. And yeah, so that's why the result is totally the same in the output. Because the shader, which is the shader that's built into Qt, so this is not something the application provided, but it's just a built-in shader which simply samples the 2D texture and does the fragment color. And yeah, the output is the same. Well, why am I showing this? Because if the engine can do this, then it's just one more step, right, to let the application change or configure, change, or inject its own shader instead. So instead of just sampling a texture, it could do something more to calculate the final fragment color. And that is more or less what a shader effect is, that we can render a QtQuick subject into a texture, then we have can draw a textured quad or some other geometry, like in some cases you may want to grid or some other type of mesh. But that's it really. So the key is to, again, let the application provide the shader. There is one additional component, which is the mapping of QML properties to uniforms in the shader. So say I have a custom property called time with the type real in QML, then in the shader I will be able to use a float uniform called time, and the Qt will of course re-render whenever the values change. So if there's an animation like a number animation on that time property, then again the scene will re-render, and then the shader will kind of see the current value. So things get nicely animated. And so putting this together, yeah, we have the ShaderEffect item. So here is a Qt 5 example. It must be noted that this example can be written in multiple ways, so not two, but even at least three different ways. So some of you may be familiar with the ShaderEffect source type, which I'm not using here because I have a layer enabled item already, which under the hood actually does create an implicit ShaderEffect source. The point is that I just need to have something which I can use as the source for that ShaderEffect, so I need a texture provider for that. And what the shader does is nothing interesting, it just maybe colorizes a bit, but what matters is that in Qt 5 you had the ability to just put in a string, because the fragment shader just has a string property, and you can just throw in the GLSL code and that's it. Of course, even in Qt 5, just with OpenGL, this already had portability issues, because some of you may know that, oh, if you are working with a modern OpenGL version, maybe have a core profile context, then this wouldn't work, because you may need to provide a GLSL for a newer version with a slightly different syntax, which is of course often a problem for libraries. Let's say you want something that works in any kind of context, then you may need to provide two versions of all your shaders. So in Qt 6, that problem at least goes away, because we anyway have to deal with graphics APIs, like multiple ones, like Vulkan, Metal, Direct3D, in addition to OpenGL. So here the top is the same, so I have a layer enabled item. I made it invisible. By the way, why did I make it invisible? Because there's no point in rendering that textured quad if then there's another quad coming right on top, right after, due to the shader effect. So it can just be invisible. But here, the big API change is that the fragment shader property is a URL. Like, yeah. It's not a string, so you can't just put in like a source code anymore. It has to really be either a local file or a QRC URL. And yeah, that's it. And it must be a file which is generated by the Qt Tools infrastructure. So Qt Tools is a new module in Qt 6, which provides, among others, this QSB command line tool, and these .qsb files are generated by that tool. If you actually try to run the Qt 5 version with Qt 6, you get some quite cryptic error message, but it makes perfect sense because you have the shader source code, which is interpreted as a relative path, and then you have, yeah, you see that it tries to convert it to an absolute path, and then, you know, tries to open that file, which doesn't quite work. And then, yeah, there's some useful pointers there what to do. Now, what I really want to point out is that in Qt 6.1, the documentation has been improved, because the first step in here is, okay, QSB and there's all that stuff, but that's not the first step. The first step is just to port the shader code, the shader source code. And how do you do that? Well, of course, it has to be Vulkan compatible GLSL, and then, especially for ShaderEffect, there are certain conventions you need to be aware of, like that, oh, there's a uniform block there, and the first 68 bytes are reserved by Qt because, you know, you have to have a matrix at offset 0 and the float opacity and offset 64. So in Qt 6.1, the ShaderEffect documentation has a dedicated section like this, migrating from Qt 5, which I highly recommend to check out if you are working with ShaderEffect. And also if you are working with custom materials in Qt Quick, like USG material, because while some of the ShaderEffect specifics do not apply, but the whole workflow and many things about the syntax, that is the same also for shaders, which you use with custom materials. So let's say that I have my shader with the new syntax. By the way, this conversion is usually pretty quickly. At least that's our experience, because Qt Quick shader effects and even materials are often quite simple. So it's not really a complicated thing to convert them. But once we have this, then what? So how do I get that shader.frag.qsb? So there's a manual way, and in fact this is what we also used internally in Qt 6.0 quite a lot, that we ran this QSB tool with an exotic set of parameters, and then got QSB files, and then packaged these up, so listed them in the QRC files or in the CMake lists, and that's it. If you are interested in the details of this, of course, Qt Shader Tools has its own documentation, so there's the whole describing the concept, the main page, and the QSB tool has its own page, like the QSB manual, which might be interesting to check out. I'm not going to cover this because there's a better way. So this is the better way, like doing it through CMake, because now that more and more applications will switch from QMake to CMake, that's good, because we have some extra features which were not ever available with QMake. And one of these features is really support for the QSB tool, so built-in support to do all this at build time. So instead of doing all that QSB calls and then packaging stuff manually, you can do this. So if I add this to the CMake lists, this function call, then, well, what this does, it runs QSB at build time, then puts the resulting .qsb file, shader.frag.qsb, into the resource system, so it's ready to be used. No need to list it in elsewhere, in Qt resources or in QRC or anything. It will be just there. So yeah, this is pretty convenient, and the nice thing is that this defaults to the settings which are usually good enough for QtQuick, so no need to specify the GLSL, HLSL, MSL options, because the defaults are usually good enough for QtQuick. Of course, in some special cases, you may want to customize it. And again, the syntax here, so this works very similarly to Qt resources, so that prefix, files, base, so those keywords work the exact same way. And here actually we have some improvements in Qt 6.2, because in 6.0 and 6.1 there were some minor differences how this worked. So the API, the CMake API, was not fully symmetrical between Qt resources and Qt shaders. But in 6.2, hopefully this is now nice and clean and identical. And the big benefit, which at least I really like, is that if there's an error in the shader, like a syntax error, then it breaks the build and prints a proper compilation error. Not like before, then if you had an error in the shader, you had to hunt for the runtime warning printed on the debug output, wherever the debug output went. So, yeah, so this will make working with shaders a bit, well, easier in many ways. When it comes to the special options, I'm not going to dive into those because it's described in the docs. What I like to mention is that if you are working with vertex shaders, then keep in mind that you need this batchable option specified if you are using those vertex shaders with QtQuick. Because again, the scene graph, we need to adjust a bit those vertex shaders due to the QtQuick scene graphs batching, and it merges things together to reduce the number of draw calls. So that needs some extra care. And finally, when it comes to this prefix, you saw that in the example I used the file URL, like the file scheme. But what is really the most convenient is that you set things up so that the shaders are next to or somewhere relative to the QML, where the .qml file is, and then the relative passes work very well. So this is now basically working like the image element source property. That, yeah, it's a URL. If it's relative, then it's resolved relative to the QML file's location. Sweet. Yes, so this is, again, I showed the QShader tools docs, the QSB docs, and of course the CMake. All this CMake stuff has its own documentation page, which I recommend checking out if you plan to use this. Now, we covered shader effects, well, to a degree at least. What about graphical effects? Because this is something that comes up constantly. In one way or another, there are questions around this, that on Qt 6.0, the Qt Graphical Effects module disappeared. In Qt 6.1, as we will see, it's back in a limited form, and then there are some future plans here. So some of you may know that the Qt Graphical Effects tries to provide a number of commonly used effects. So instead of each and every application writing its own custom shader effect for a, say, drop shadow or blur or colorize effect, there are some ready-made ones. This has grown during the lifetime of Qt 5, adding some quite complex, like all those blur variants, some quite complex effects. And it also has some, well, some issues, so it's fairly easy to shoot yourself in the foot with this when it comes to performance. Because it could be that an effect itself is too heavy for example, if you are targeting a somewhat low-powered embedded or mobile device. And then there's another big problem of combining these effects, that if I want let's look at the example, like if I have a colorize and drop shadow together, then this is not really done in an efficient manner, because what this does is that, again, there are multiple passes with intermediate textures. So render a texture, the source is rendered into a texture, then we draw a textured quad to another texture, then use the output, the result from there in another pass, and so on and so on. So this, again, doesn't necessarily perform very well, again, depending on your target platform. So this was a Qt 5 example, but it is actually possible to port this to Qt 6, because, again, this is a new thing in Qt 6.1. So in Qt 6.1, in the QtsCompat module, we have Qt Graphical Effects, so at least 17 of the 25 effects are available. And this works with all of the supported graphics APIs like Vulkan, OpenGL, Metal, Direct 3D. But some things, like some of those complex blurs, are removed, and some of the effects work slightly differently. So, for example, the drop shadow always works as the fast version of drop shadow worked in Qt 5. But this is still pretty useful, because just by changing the import, like I switched to import QtsCompat.graphical effects, yeah, I can make this application work with Qt 6. So in many cases, I think this will be very useful when you want to port something existing. But when it comes to new things, it is likely that you may want to use something else in the future. So some of you may know that for Qt 5 we have something called Qt Quick MultiEffect on the Qt Marketplace. So the package there contains some QML types which you can include, like ship with your own application. And what this does, that it provides some of the most commonly used effects like blur, shadow, colorize, mask. But it does it a bit differently than Qt Graphical Effects. So pictured here is the screenshot of one of the examples, which is basically a test bed, and you can see I have blur, shadow, colorize, and mask enabled. But the nice thing here is that this comes at no additional cost, so the combination of multiple effects. So the source here, don't look at this too much, because who knows, maybe the Qt 6 version, which hopefully coming at some point, may be different, but the concept is there, right? So now I have a single effect item which I configure according to my needs. That do I want colorize, shadow, or blur? And again, a render.capture just to show the concept, why this is really important. So you can see that in the shader there is stuff that's related to the blur, stuff related to the colorize, and stuff related to the shadow. So basically we can apply multiple effects in a single pass. Of course there are multiple render passes in that capture, because the blur and shadow, so the blur based things, need those anyway, but still the main effect pass that has all effects combined into a single shader, which is not something you can do with Qt Graphical Effects. And now very quickly let's talk about Qtfix 3D. Again, a simple example, there's a directional light and there's a cube, and what matters again is at the bottom, the last line, materials, custom material. What is a custom material? Well, so again, the concept is somewhat similar, like in Qt Quick, that you can have your own shaders, other things provided to have more control over how the whole mesh is rendered. But this is a bit slightly different in 3D. So this example here, so the custom material here is completely identical to principled material. So the output is the same if I write principled material, custom material, which is because the most commonly used mode of a custom material is this so-called shaded mode, where we basically augment a principled material, so you get the full lighting from the engine. So for example, the directional light, if there were shadow casting lights, so all this stuff, the lighting, the light contribution, the shadow contribution, that's taken into account by default, because you are just extending the default material, you are not specifying the full shader. Which may sound familiar if you used other tools, so for example Godot, the spatial shaders, or I suppose at least that Unity surface shaders are something similar, whereas we have the less commonly used unshaded mode, which is you lose all the lighting. So with that example here, the directional light would have no effect, because if you are providing your own shader or your own logic, then that's gone, that's not very useful. You have to calculate the final fragment color on your own, which again has equivalent in other tools like Godot, unshaded spatial shaders, or of course Unity has similar things. So a simple example which shows that in some ways this is actually reminding us of ShaderEffect a lot. So okay, there's a vertex shader, fragment shader property, where we refer to files. We have custom properties like that time, amplitude, we can animate them, and they of course can be used in the shader. But the big difference is that here we are actually referring to source snippets, because you see that the material vert and material frag, these really contain snippets which also have some special keywords like the uppercase ones. So that's QtQuick3D's own special keywords. And then it will be up to QtQuick3D to assemble this into a real shader under the hood in the engine. So what this would give me is like where we animate some of the vertices, like the vertex position, and then, yeah, we change the base color. Of course, it's not very interesting because you could achieve that green base color also by using a principled material and setting the base color property to green. But the nice thing here is that it's up to the shader how it calculates that color. So it could sample a texture, sample multiple textures, accumulate things, so calculate things in any way it wants to, or based on, of course, uniforms that are connected to QML properties. Yes, so the connection with properties and uniforms, that's very similar. It's a bit not always the same as in QtQuick. For example, for colors, now there are some considerations when it comes to linear versus sRGB, because QtQuick3D does tone mapping by default at the end. But of course, how you work with textures is slightly different in some ways, because there are dedicated types like texture and texture input in QtQuick3D. But the concept is completely the same, so it should be familiar and easy to get started. Again, the language is Vulkan compatible GLSL, so same as QtQuick materials effects, but here again you have to provide source snippets which are not complete shaders on their own, and there are lots of special keywords which you will probably use a lot. And why is this? Because, so this is again a rendered capture, so that example, when I render that cube, so I have a fragment shader of, I don't know, 252 lines, whereas my custom material provided, 4 of those. So again, that's why I said that it's QtQuick3D will assemble and inject your custom code into a bigger shader. So in 3D, things with all the lighting and stuff, things are a bit more complicated as in QtQuick, as in the 2D world. This is just some, again, pointing to the documentation. So custom material should have some fairly extensive documentation. There's also a tutorial in the QtQuick3D docs, and custom material has its own documentation page. Yeah, like just an outline of some of the special keywords available in a vertex shader, or maybe I should say vertex snippet. Similarly, for the fragment shader, when I'm using a shaded custom material, there are things like base color, metalness, roughness, which might be familiar from principled material. And then there are some other things which, you can calculate things based on them. So this whole system has some pros and cons, but this seems to work pretty well for now, so that we do all this shader processing at runtime. I must mention that there are ways, if you are interested, to get around this, so search for build-time materials in the QtQuick3D documentation, because there is an experimental solution to not have to pull in the whole shader tools module and not have to really compile and process and generate metadata and all that stuff at runtime. But that has also its pros and cons because it has some restrictions. So build-time materials is the keyword if you are interested. And yeah, these are the 2 documentation pages I mentioned, custom material, and then there's a very handy tutorial page for materials and effects in QtQuick3D, which I highly recommend. And that's it.